In this session, we will learn how to plot IV curve for photovoltaic cell based on temperature at constant illumination. At the end of this session, you will be able to know the standard test conditions or STC, describe the equipment solar simulator, explain the characteristics of solar cell of a PV module, and detail on the IV characteristics of PV cell for variation in temperature on cell.
Let us learn about the standard test conditions of a PV module. Every manufacturer tests their modules under standard test conditions, which is a set of rules to follow at manufacturing industry. These rules allow consumers and solar designers to compare panels. Normal STC includes solar cell temperature of 25 degrees Celsius, solar irradiance of 1000 watt per square meter, and the air mass 1 or 1.5. The air mass is the path length which light takes through the atmosphere normalized to the shortest possible path length. The air mass quantifies the reduction in the power of light as it passes through the atmosphere and is absorbed by air and dust. Air mass is the measure of how far light travels through the Earth's atmosphere. One air mass or AM1 is the thickness of the Earth's atmosphere. AM 1.5 is almost universal when characterizing terrestrial power generating panels. A solar simulator is a light source that has specific quantifiable similarities to natural sunlight, namely in its spectral distribution and intensity. It may also be referred to as an artificial sun or sunlight simulator. The solar simulator has special air mass filters and lamps to simulate the sun's solar spectrum. The purpose of a solar simulator is to provide a consistent, controllable source of illumination in a laboratory environment for testing any materials or processes that are photosensitive. The solar cell IV characteristics curves shows the current and voltage IV characteristics of a particular photovoltaic cell, module or array. It gives a detailed description of its solar energy conversion ability and efficiency. Knowing the electrical IV characteristics, more importantly P max of a solar cell or panel, is critical in determining the device's output performance and solar efficiency. Photovoltaic solar cells convert the sun's radiant light directly into electricity. The graph shows the current voltage characteristics of a typical silicon PV cell operating under normal conditions. The power delivered by a single solar cell or panel is the product of its output current and voltage. If the multiplication is done point to point for all voltage from short circuit to open circuit conditions, the power curve is obtained for a given radiation level. When the solar cell open circuited is not connected to any load, the current will be at its minimum, 0, and the voltage across the cell and its maximum, known as the solar cell open circuit voltage or VOC. At the other extreme, when the solar cell is short circuited, that is, the positive and negative leads connected together, the voltage across the cell is at its minimum, 0, but the current flowing out of the cell reaches its maximum, known as the solar cell short circuit current or ISC. Here is the IV curve of solar panel. PV panels can be wired or connected together in either series or parallel combination or both to increase the voltage or current capacity of the solar array. If the array panels are connected together in a series combination, then the voltage increases, and if connected together in parallel, then the current increases. The electrical power in watts generated by these different photovoltaic combinations will still be the product of the voltage times the current. However, the solar panels are connected together the upper right hand corner will always be the maximum power point of the array. Now, let us do a task to test your understanding on the concepts learned. You need solar simulator equipment, thermometer, and solar energy meter to perform this task. Your task is to study the IV curve for 3 different temperatures on solar PV cell with constant intensity. Connect the solar simulator equipment to mains power supply and switch on. Set both the intensity control rotary switch of lamps at maximum position to get the full intensity. Measure the intensity using solar energy meter and record the observed value. Measure the room temperature. Record the observations. Use the temperature controller and set a value little above room temperature. Set the potentiometer to maximum to get no load condition. Measure the voltage and current of solar cell at no load condition on display. Vary the potentiometer towards minimum. Measure the voltage and current of solar cell at full load condition on display. Record the observations. Repeat the steps above with temperature at still higher set value. Record the observations. Draw the graph for normal, higher, and much higher temperature values and compare. Record the observations.
We have reached the end of this session on plot IV curve for photovoltaic cell based on temperature at constant illumination. By now, you should be able to know the standard test conditions or STC, describe the equipment solar simulator, explain the characteristics of solar cell of a PV module, and detail on the IV characteristics of PV cell for variation in temperature on cell.